Yo, Miss Aketa, why are we doing this? I just don't know why we keep doing this. Yeah, I mean, I'd rather be working out right now. Miss Aceta, can I do a project on what the color of pizza is? Anyway, this was brought to you by T-Test for Mean, lesson 8.3. I thought you would enjoy that because you know I miss you. Write all these notes down for me. When the population standard deviation is unknown, we use a T-test. Yes, we've known that. Kelsey even knew it, right, Kels? See, I need to talk to people. We use a T-test for mean. T-test for mean. Okay, so what does that mean? What does that look like? We are going to use a test statistic. It's going to be a T now, not a Z. Okay, and these should all be obviously obvious to you. I don't even know what I was going to say. Obviously obvious to you. This is our sample mean. This is the population mean. S is your sample standard deviation. And N, obviously, you know what that is. Number in your sample. Now, just two quick assumptions about when using the T-test instead of the Z-test, just like when we were doing it for confidence interval. Assumption number one is the sample is random, obviously. And then number two, either you have N is greater than or equal to 30 things, or your population is normally distributed when you have less than 30 things, okay? But again, you use this test when your standard deviation and population is unknown. Why do I keep saying obviously? No idea. All right, so we got 2 examples to do, and it's similar to what we've been doing, just using a new test statistic, okay? So number 1, a medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. Sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at 0.05? Assume the variable is normally distributed. Okay, so we are noticing that we have a sample of 10 weeks, which is less than 30 things. But we know that we're assuming our variable is normally distributed. So we're going to use a T-test. So you're going to end up going to stat tests, and instead of Z, we're going to go to T-test. And again, you only use the T-test when your standard deviation for the population is unknown. Okay? So step number 1, let's find out what our HO and HA is. Okay, so we are looking to see the medical investigation claims the average number of infections per week at a hospital is 16.3. So we think the average is 16.3, but a researcher, an investigator wants to know, can we reject this? Meaning, what? Is it less than? Is it greater than? Is it different? Just meaning, is it different? Can we reject this? So is it different than 16.3? Step number 2, state your significance level. Your significance level is 0.05. State your critical value. Your critical value T, now this is going to be different. You are going to be looking for the critical values that make this a two-tailed test because it's not equal to. We want both of these together to add up to 0.05, which means that separately they're 0.025. So how do we find that number? You don't go to inverse norm. Listen, if you have to write this down, write this down. You go to inverse T. So go to second bars, inverse T. The area is, again, from left to right, we're going to do the 0.025. And what does DF mean? You know that's degrees of freedom. Degrees of freedom is always one less than the sample. And so our sample would be of 10 weeks. So we're going to put 9 right here. And that is an inverse t-value of negative 2.26. So our t critical value is plus or minus 2.26. Plus or minus 2.26. Step number 3. Now you're going to calculate your own t-value from your sample. So we're going to use t equals x bar minus mu over our sample divided by square root of n. So let's look. What is the average in our sample? A random sample had a mean of 17.7 minus the mean population was 16.3 divided by the sample standard deviation 1.8 divided by the square root of n, which is 10 weeks. And that is 2.45. Step number 4. Well, actually, before we do step number 4, let's write our p-value. And how do we find out our p-value? In the calculator. So we go to stat, test, not z-test, t-test. You're going to go to statistics. You're going to input your population mean, which was 16.3. Your mean sample, 17.7. Your sample standard deviation, which is 1.8. And our sample was 10. We choose the not equal to because it's a two-tailed test. Oops. And then calculate. Look at that. Our t is 2.45, which is what we got. And our p is 0.036. That's what we want to write down. So number 4, do we reject or not reject? Is this greater than or less than our 0.05? Highlight this for you. 0.03 is less than 0.05. Aha! If the p is low, reject the HO. And number 5, you would say then if you're rejecting, that means there is enough evidence to support the claim. And what's the claim? What's the investigator's claim? That the average number of infections is different than 16.3. That the average number of infections is different. Okay. All right, one more. Chocolate chip cookies. I've already pre-put this into my calculator, by the way. The average 1 ounce chocolate chip cookie contains 110 calories. A random sample of 15 different brands of 1 ounce chocolate chip cookies resulted in the following calorie amounts. At the 0.01 level, is there sufficient evidence that the average calorie content is greater than? All right, so number 1, HO, we think the average calorie is going to be 110. I'm sorry, we don't think that. We think that is what the claim is, but we're saying that it's actually going to be greater than 110. Step number 2, our significance level is 0.01. Okay, let's kind of pre-highlight this. Our t-value, critical t-value. How do I get that? From the calculator. Inverse t. And again, if I'm greater than, let's draw this out. I think drawing would help you out. Greater than would be right here, 0.01. I can't put that in my calculator. I have to put this side, the left side, which is 0.99. So I'm going to inverse t, 0.99. Inverse t, 0.99 And what would be the degree of freedom? Degree of freedom. How many these calorie chocolate cookies did I have? 15. Don't put 15, put 14. And I get an inverse T of 2.62. Critical value T is 2.62. Okay. Number 3. Now you create your T value from your sample. T equals X bar minus mu over over square root n. So that would be, again, how do I get X bar? I've already put it in here in my list. You can go to 1vars and get your mean, 137.3. Minus the mu is 110 calories. Divided by my sample standard deviation, 24.1. And divided by the square root of 15. And I'll give that to you. It turns out to be about 4.39. Okay, we need to find our p-value. This is done from doing stat tests t-test. And we're going to go to data because I've already entered it into L1. Sorry, there's a glare. And I'm just going to input my population mean, which was 110. And I want to make sure I choose the greater than. And look at here, what do we got? 4.39 is our T. Our p-value is 3.0, e to the negative 4. Ooh, that is tiny again. So 0.0003. Is that less than 0.01? You betcha. You betcha. Okay. So that means for number 4, you are going to reject the HO. Move this up. And number 5, you would just say there is enough evidence to support the claim. What's my claim again? That the average calorie content, let's say that. Calorie content is greater than 110. 110 calories. Okay. So try your homework. Send me a picture. Hope you enjoyed the first part of my lesson. Bye.